but I wasn't sure if I was allowed to.
Nom nom.
Hello, I'm AJ Prasad, and I'm here to talk to you today about the universe,
Yeah.
space, time, and the vastness. I'd like to start off. Astronomer, astrophysicist Carl Sagan once said, "The total number of stars in the universe is greater than all the grains of sand on all the beaches on planet Earth." See stars there in the sky. There's plenty stars, plenty sand on a beach, and that's just one beach on Earth. Earth has plenty beaches. Beaches have sand. Deserts have sand.
It's true.
Lots of sand, lots of stars. Keep it going. It's difficult to fathom the sheer vastness of the realm outside of Earth we call space. As you can see, we live in a pretty small world. That's Earth right there compared to our big bro Jupiter. We're just like the biggest of the rockier planets, closer to the sun. So let's take a journey through space. Pretend we are a light energy particle that was emitted from the sun. Boom! The speed that light travels in a vacuum of space is 299,792,458 meters per second, or 186,000 miles per second. So imagine we're flying through space at 186,000 miles per second. Continue that for 8 minutes and we'll hit Earth. If you move at the speed of light for 8 minutes from the sun in the direction of Earth, you're going to hit where the Earth orbits around the sun, the circular thing. It takes about 8.3 minutes for the sun's light to reach Earth. So the sun stopped shining. If the sun stopped shining right now, we would experience sunlight for 8.3 minutes before we were in complete darkness. That'd be pretty intense. If the sun just burnt out. We wouldn't know it for 8 minutes. What would we do? So imagine continuing that speed of light for another 5.5 hours. We would reach the planet that I still consider a planet, Pluto, because that's what they taught me in elementary school. So hey, it's still a planet. Our Earth and Pluto would merely look like a pale blue dot. Our own sun would look almost like any other star in the sky. So, see Pluto, for those of you who care. The moon, Pluto, and then that's our sun way over there. What's center warp speed, people? Flying through time. 4.2 years at light speed. So that's at 186,000 miles per second for 4.2 years straight. You would just reach our sun's closest neighboring star, which is called Proxima Centauri. The star would be the center of the closest solar system to Earth. The distance that light covers in 1 year of uninterrupted travel is known as a light year. This distance is about 6 trillion miles per year. That's 6 with like 12 zeros. That's pretty fast. So it would take an astronaut about 4 years of flying through space at the speed of light to reach the closest star to our sun. That's 4 years at the speed of light. We can't go faster than the speed of light. Not possible. But there are about 4 billion other stars in our Milky Way galaxy alone. 400 billion. It's a lot. Anyway, so how does our sun compare to other stars? Well, you got Earth down here, pretty tiny. The sun is gigantic compared to Jupiter, which is pretty big compared to us. But it gets bigger. That's the sun. Earth would be invisible. Jupiter is 1 pixel in size on this computer screen. That's compared to Pollux and Arcturus. Pretty big stars out there, man. Telling you. So this is Aldebaran, and then the sun, the No, compared to Aldebaran. Aldebaran is a red giant. Ours is just like a small, average, young sun star. But anyway, that planet was the sun compared to Aldebaran. That right there, Aldebaran sun. Compare Aldebaran to Antares or Beltagais. This sun is 1 pixel. Like, come on, it's so big. Like, what? What the heck, man? So, the solar system is situated on the outskirts of the Milky Way. We are about 28,000 light years from the galactic center. So, going 6 trillion miles an hour, for 28,000 years, you would only reach the middle of our galaxy. Now, take that thought. Our Milky Way has a span of 100,000 light years. So, say you shined a flashlight from this side to the other side of our Milky Way galaxy, it would take 28,000 years at the speed of light to just reach across our own galaxy. Now take that and imagine 2.9 million years at the speed of light. 2.9 million years at 6 trillion miles an hour. You would just be arriving at our most significant neighboring galaxy, Andromeda M31. That's the same speed that we reach Pluto at in 5.5 hours from our sun. Now, seeing how widespread galaxies can be from each other and how many galaxies are in the universe, recent calculations show that there are about 130 billion other galaxies in our universe. We live in the Milky Way. There's 130 billion other galaxies. So, the Hubble Space Telescope, which is in the sky flying right now, studied this little segment of the night sky. This is, if you just looked up, just probably a couple square inches. Now, Hubble focused on that little segment of space for a couple months' time. It's extremely expensive and lots of research was done. And this is what they came up with when they brought all the images together, and it's called the Deep Field Space Image. And that's what you get. As you can see, thousands of galaxies, stars, all kinds of stuff. Endless. And that's in one little section of the night sky. That's focused in. So, to wrap it up, if we left our sun beginning of the presentation, it would take 2.9 million years starting for Andromeda to see us as light. That's our closest, biggest galaxy. Looking at Andromeda from Earth at night, the light you are seeing emitted from the galaxy is 2.9 million years old. So if you looked at it, it would be 2.9 million year old light that you're seeing. Say tonight you see a supernova explosion in the sky that's 20 light years away. That means that the explosion happened 20 years ago and the light is just now reaching Earth. So when you look at the night sky at night, look at the sky at night, remember that all the stars' light that you're seeing is from the past. So that's the center of the Milky Way that we can see visibly from Earth after a long period of focusing it with the telescope. And if that's 20,000 light years away, that light that you're seeing in the picture is 20,000 years old.
50 seconds.
That's it. I'm AJ Prasad. That's space and the vastness of it. It's crazy stuff.
Now what? You have to introduce yourself.
I'm Sam. And I'm Gary
I'm John and I approve this message.
I'm Guavel.
Yeah.